Hello students, today we are starting exercise 1.2 third problem. See children, here third problems are given. Find the LCM and HCF of the given integers by applying prime factorization method. Now what you have to find out? So you need to find LCM and HCF of two integers by applying the prime factorization method. Okay, the first problem 12, 15, 21. So we know how to find prime factorization. For 12 prime factorization, can you see this? From 2 it is 6, again from 2 3, from 3 it's 1. So prime factors of 12 are 2 into 2 into 3. So 2 into 2 means 2 square into 3. So this is the prime factors of 12. Again we'll take prime factors of 15. See, from 3 5s are 15. Again from 5 1s are 5. Okay, so prime factors of 15 are 3 and 5. Again 27. 3 7s are 27. 7 1s are 7. The prime factors of 21 is 3 into 7. HCF of 3. HCF. See, the HCF of this number is 3. How did you get this? You can see here 3 is present in 12. 3 is also present in 15. 3 is also present in 20. Means 3 is a factor of 12, 15 and 21. That is the least factor and the highest factor. Why it is highest factor? Because 2 is not here in 15 and 21. 5 is not here in 12 and 21. 7 is not here 15 and 12. So only one number is common in these three, that is 3. So that's why HCF is 3. Now come to the LCM. How to find LCM? So you know, first HCF, write down the HCF into and leave the HCF common factor, and the remaining thing, which is the remaining thing, 2 to the 4. Again here in the 15 is remaining is 5. 21 is remaining is 7. Okay, so multiply all these numbers, 3 into 4 into 5 into 7. When you multiply, you will get 420. So LCM is 420. Okay, we'll move to the next problem. That is LCM of HCF and LCM of 17 and 23, 29. You can see here 17, 23, 21. By looking at, we can conclude that these are prime numbers. Why? Because it has a factor 1 and 17. 23 is a factor 1 and 23. 29 has a factor 1 and 29. So therefore HCF is 1. Because 1 is common to all. So that's why HCF is 1. So what is the LCM? LCM means you need to multiply all these three, 17 into 23 into 29. So when you multiply, you will get 11,339. That is LCM. Okay, so next move on to the next problem. The next problem is to find the HCF and LCM of 8, 9, 25. Okay, so the factors, the prime factors of 8 are 2 into 2 into 2. The prime factors of 9 are 3 into 3. The prime factors of 25 are 5 into 5. Okay, can you tell me which is a common here? So except 1 there is nothing is common. That's why HCF is 1. Okay, so next we'll go to the LCM. LCM means already I said that multiply all the 3 numbers because no common factor. So multiply all these things, you will get 1800. So LCM is 1800. Okay, we'll move to the next question. The next fourth question. Given that HCF of 306 and 657 is 9, LCM of 306 and 657 is what? You got it? So HCF of the two numbers are given, that is 9. So you need to find the LCM. You know the result, A into B is equal to H into L. This is the result. A means a number, you can take 306. B is another number, you can take 657. So is equal to H into L. So H is already given. See, the HCF of 306 and 657 is 9. So in place of H you can put 9 into L. Okay, so you need to find the value of L. L means LCM. So take 9 this side. 9 how many times? 657, 73 times. And when you multiply 306 into 73, you will get 27,338. So that is the LCM. Got it? Okay. The next question, fifth question. Check whether the 6 to the power of n can end with the digit 0 for any natural number n. Check whether the 6 to the power of n can end with the digit 0 for any natural number n. So look at that, 6 to the power of n. So 6 to the power of n means natural number. And already told that natural number 1, 2, 3. Now I'll put the natural number system here. 6 to the power of 1 is 6. 6 to the power of 1 is 6. 6 to the power of 2 is 36. 6 to the power of 3 is 216. You can see the digits is not end with 0. Okay. Okay. Now we'll see why it is not end with 0. If the number 16 can be end with the 0, it would have been divisible by 5. Got it? It would have been divisible by 5. It is not divisible by 5. So that is prime factor of 6 to the power of n is containing the prime 5. This is not the possible. This is not possible. Why it is not possible? Because it is not divisible by 5. 6 to the power of n have a factor 2 into 3 to the power of n. Do you agree with it? 2 into 3 to the power, and that can be written as 2 to the power of n into 3 to the power of n. So that's why the only prime factorization of 6n are 2 into 3. So there is no natural number n for 6 to the power of n end with digit 0. Got it? The factors of 6 always will be 2 into 3. So if 2 to the power of n and 3 to the power of n, the only prime factors of 6n. So no natural numbers will end with the digit 0. Got it? The sixth question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 1 into 2 into 1 plus 5 are composite numbers. The first of all, you know what is composite number? Composite numbers are more than two factors. They have more than two factors. Okay, so we know that prime numbers can be divided by 100 itself, where composite numbers as factors other than 100 itself. So first we'll take 7 into 11 into 13 plus 13. We'll take 13 as a common factor. See, 13 is here and 13 is here. Take 13 common factor. What is remained here? 7 into 11 plus 1. See, taken 13 as a common factor. So 13 into 77. 7 11s are 77 plus 1. So 13 into 78. 13 into 17, it can also write 13 into 13 into 6. 13 into 13 into 6. 13 6 are 78, right? Okay, so 13 and 6 are its factor. 13 and 16 are its factor. So this is composite number. Okay, then next we'll take 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now take 5 as common factor. As I said, take 5 as common factor. So what is the remaining? 7 into 6 into C. 5 I have taken outside. 4 into 3 into 2 into 1 plus 1. So multiply all these things, you will get 1008. So 1008 plus 1 is 1009. So 5 into 1009. So 1009 cannot be factorized further. So that's why it is a composite number. So the next question, 7th question, that is the last question. There is a circular path around the sports field. Sonia takes 18 minutes to drive one round of the field, whereas Ravi takes 12 minutes for the same. Suppose they both start at the same time and at the same point and go in the same direction. After how many minutes will they meet again at the starting point? Okay, so this is the question. Now, by looking at this, we can say this is a question of LCM. Okay, so this you have learned in the 6th standard itself. So we need to find the LCM of 12 and 18. Now take 18, the factors of 18. The prime factors of 18, 2 into 3 into 3. See, 2 9s are 3 3s are 2 into 3 into 3. Factors of 12, 2 into 2 into 4, 2 into 2 into 4. Now what is the LCM? LCM is the highest power of the prime factor. See, here we'll take 3 square, here we'll take 2 square. 3 square, 2 square is 9 into 4, that is 36. So they will meet again at the starting point after 36 minutes. After 36. Got it? Okay. So next we'll see, prove that root 2 is an irrational number. It's a very important question. Root 2 is an irrational number. How to prove root 2 is an irrational number? Okay, let us assume this. Proof. Let us assume to a contrary that root 2 is rational number. Let us assume to contrary that root 2 is rational. Root 2 is rational. Okay. So we can find the integers. Find the integers root 2 is equal to r by s, where s is not equal to 0. So first what we have to do, for root 2 we need to assume that root 2 is a rational. So we can find the integer root 2 is equal to r by s. So s is not equal to 0. Okay. So suppose r and s have a common factor other than root. Suppose r and s, suppose r and s have a common factor other than 1. Have a common factors other than 1. Now we need to assume that r and s are co-prime. R and s are co-prime. Co-prime means it has only having the common factor is 1, not other than 1. Okay, so that's why we can consider this is co-prime. So then we'll get root 2 is equal to a by b. So where a and b are co-prime. What are co-primes? Co-primes are the numbers they don't have other common factor than 1. So they have common factor only 1. See, a and b has a common factor only 1. Okay, the next. So what we do is root 2 is equal to a by b. Now I'll take this b to the left hand side. B is equal to root 2 b a. Sorry, b root 2 is equal to a. B root 2 is equal to a. Squaring both sides, b root 2 whole square is equal to a square. B square into 2 is equal to a square. Got it? Here 2 divides a square. 2 divides a square. 2 divides a square, and also 2 divides a. 2 divides a. So we can write a is equal to 2c. a is equal to 2c for some integers. For some integers. So a is equal to 2c for some integers. Okay, substituting for a we get what will substitute? 2b square is equal to a. For this you are substituting 2c. Okay, 2c square, that is from 2c. So a square this number, a square is equal to 2c, so that is 4c square. So 2b square is equal to 4c square. 2 ones are 2 twos are, so b square is equal to 2c square. B square is equal to 2 squares. This means 2 divides b square. Means 2 divides c square. 2 divides c square. B square, and 2 divides b square, and 2 divides b. Two divides b. So therefore a and b has a common factor 2, isn't it? So initially we assume that a and b do not have common factor other than 1, but here we can see that a and b has a common factor 2. So this contradicts the fact that a and b have no common factor other than 1. So this contradiction arise because of our incorrect assumption that root 2 is rational. So that's why root 2 is an irrational number. Got it? So this is how you can do. So prove that root 2 is an irrational number. So quickly recall how we have done. So first you see the proof. We need to prove that root 2 is an irrational number. Root 2 is an irrational number. Proof. Let us assume that contrary that root 2 is a rational. First we have to take root 2 as a rational number. So we can find the integers root 2 is equal to r by s. So when we assume that it's a rational number, we will take this as a p by q form or r by s form, where s is not equal to 0. Suppose r and s have a common factor other than 1. Okay, r and s have common factor other than 1. So root 2 a by b, we'll take a by b. This is also a rational number where a and b are co-primes. What are co-primes? Co-primes are the numbers which have only one common factor, that is 1. So now a and b are co-primes. Now cross multiply, b root 2 is equal to a, squaring on both sides, you will get b square 2, that is equal to a. See, 2 divides a square. You can see that 2 divides a square and also divides a. 2 also divides a. So if it is divides a and a square, then why don't we take a is equal to 2c? Okay, so c is also an integer. So square on both sides, you will get a square is equal to 4c square. Now look at that, a square is also equal to b square 2 and it's also equal to 4c square. So when we divide, you will get b square is equal to 2c square. So 2 divides b and also b square. Then, so therefore a and b has a common factor 2. So it has common factor 2, right? So initially what we have assumed that a and b has a common factor 1. If they are, we have considered that is co-prime. But here they have common factor 2. This contradicts the facts that a and b have no common factor other than 1. So this contradiction is arisen because of the incorrect assumption of root 2 is a rational. So that's why root 2 is an irrational. Got it? So this is how you are going to solve root 2 is an irrational number. Okay, in exam they will ask this type of questions. So prove that root 2 is an irrational number. Okay. So quickly recall that what we have learned.